This is part 3 in production, and today we will discuss a tool that is Isoquants. So what are Isoquants? Then what is its use? So that kind of things we will analyze. So first of all, what is an isoquant? An isoquant is a curve which shows various combinations or different combinations of two inputs which gives the same level of output. See, we can take different combinations of two inputs. Suppose these two inputs are labor and capital. Sorry. We can take different combinations of this labor and capital, but we are taking the combination in such a way that all these combinations gives the same level of output. All the combinations gives the same level of output. In that way only we are taking the combinations of these two inputs. For example, a table is given here. See, first we are taking a combination 5 units of labor and 9 units of capital. Then 10 units of labor and 6 units of capital. 15 units of labor and 4 units of capital. So whatever may be the combination, we are getting 100 meters of cloth. So one more thing we can understand from this table. When you are increasing the number of units of labor, we are decreasing the number of units of capital, so that we are getting the same level of output. So when see, iso means equal. Iso means equal, and quant means quantity of output. So in short, we can say isoquants means equal product or equal quantity of output. So it is also called iso product curves or equal product curves. Equal product curves, because if you take any combination or any point on the isoquant, we will get the same level of output. Whatever may be the point that we are taking, we are getting the same level of output. See the diagram. So in the diagram, we are getting a curve. If you convert this schedule into a graph, we will get a curve like this. It is a downward sloping curve. This downward sloping curve is isoquant. And in the y-axis we take capital and x-axis we take labor. So if you take any combination of labor and capital, we are getting 100 units of output. So this is an isoquant. Then another important topic is the properties of an isoquant. What are the properties of an isoquant? See, isoquants are negatively sloped. Isoquants will always slope downwards, or it is negatively sloped. What will be the reason? So we know that on an isoquant, the total output remains constant. Whether we take a point, the uppermost side or the lowermost side, wherever it is, the total output remains, the total output that we are getting, that remains the same. So when we increase the quantity of one input, we have to decrease the quantity of the other input. Then only we will get the same level of output. So that is why the isoquant is negatively sloped. Why? Because when we increase the quantity of one input, we are decreasing the quantity of the other input. So that is why it is negatively sloped. Then second important property is isoquants are convex to the origin. See, what is the meaning of convexity here? So along the isoquant, MRTS LK. MRTS LK means marginal rate of technical substitution of labor for capital. So what is this MRTS LK, or marginal rate of technical substitution of labor for capital? That means it is the rate at which one input is replaced by the employment of additional units of the other factor or other input. So here, when you employ one more labor, how much capital you are replacing? So that rate is called MRTS LK. So it is the rate at which one input is replaced by the employment of additional units of the other input or other factor. So when you look at this diagram, you can understand one thing. That means when you employ more and more units of labor, what happens to the amount of capital replaced? We can draw another diagram for that. See, suppose drawing an isoquant. Suppose this is the isoquant, and when you employ the additional unit of labor, you are replacing this much of capital first. Then the next unit of labor, how much of capital we have to replace? This much only. That is less. Again, for the next unit of labor, we replace this much of capital only. So this rate of replacement, that goes on decreasing. That is why the isoquants are convex to the origin. Here we can explain some other important features of this convexity. See, when you employ an additional unit of labor and we are replacing a certain quantity of capital, see, because of the replacement of capital, we are losing certain output, certain quantity of output. And because of the employment of the additional unit of labor, we are able to contribute certain quantity of output. These two must be same. Otherwise, the total output may vary. But along the isoquant, the total output remains the same. So in this case, it is 100. So since it is 100, that should not vary. So when you employ an additional unit of labor, how much output that you can contribute? That must be equal to the loss in output because of the replacement of a certain quantity of capital. So that we can write as, see, when you replace some capital, how much output you are losing? That is minus of delta K into MPK, that is marginal productivity of capital. So marginal productivity of capital multiplied by the amount of capital that you are replacing. This much output we are losing. Marginal productivity of capital means how much output is contributed by the last unit of capital that we employ. So that output multiplied by the amount of capital that we are replacing. So this much output we are losing. That must be equal to the amount of output that we are getting when we use additional units of labor. That is, the additional employment of labor is delta L, that multiplied by marginal product of labor. When you add these two, how much we are losing and how much we are getting, this must be equal to 0. Then only the output remains constant along the isoquant. So when you rearrange this equation, you will get minus of delta K divided by delta L is equal to MPL divided by MPK. So what is delta K divided by delta L? In the diagram, actually delta k by delta is the slope of the isoquant. That is the rate at which the one input is replaced. That rate is the slope. So delta k by delta L, the slope of the isoquant is equal to MBL by MPK. That is the ratio of marginal product of labor to marginal product of capital. So this is the slope of the isoquant. So we have derived the slope of the isoquant here, that is MBL by MBK. So that much only about the convexity of isoquants. The next important property is two isoquants never intersect. If two isoquants intersect, at the intersecting point what happens? In the intersecting point, the output must be same, but it is not possible. When we take two different isoquants, the output will be different. So it cannot be same at this point. So that is why we say never two isoquants intersect, or two isoquants cannot be intersected. So that is another property. Then last one is higher isoquants represents higher levels of output. So this isoquant represents a particular level of output, that is 100. But if you want to represent 150 units of output, you must draw a higher isoquant. So this will be 200 units of output. So that means higher isoquants represents higher levels of output. So usually isoquants slopes downwards from left to right. But there are certain special isoquants. So now we can see what are these special isoquants. See, the slope of the isoquant depends on the substitutability of the factors, or it is called elasticity of substitution. That is, to what extent the inputs are substitutes, or we can substitute one input for the other input. So that is usually the isoquants are negatively sloped. That is, there is substitutability is there, but to a limited extent. But when the isoquants are perfect substitutes, an isoquant will be linear and it will be a downward sloping straight line. So if the isoquant is a downward sloping straight line, it shows that, so on a straight line the slope will be the same. That means the amount of capital replaced by one additional unit of labor, every time it will be the same. So that means there is perfect substitutability. Another possibility is sometimes a special type of isoquant is right angled isoquant. When an isoquant is right angled, there is zero substitutability. Substitutability is not there. Only those combinations which come at the corner, only that points are feasible, or only that points we can produce. So there is zero substitutability. So that is the implication of right angled isoquants. So these are the two special type of isoquants, downward sloping straight line and right angled. If it is downward sloping straight line, there is perfect substitutability, and a right angled isoquant means there is zero substitutability. Next, we will study an iso-cost line. What is an iso-cost line? An iso-cost line shows various combinations of labor and capital, or two inputs, that can be purchased for a given expenditure of the firm. That means with a given amount of money, how much of these two inputs can be purchased. In other words, it shows various combinations of labor and capital that is available to the firm at the same cost. That means the same amount of money at given prices of inputs. That is an iso cost line. So if you take any point on the iso cost line, it gives one particular combination of labor and capital. So if you take any combination, the total expenditure, the expenditure we are spending for that particular combination will be same. Wherever you are taking the combination, the total money spent by the producer will be the same, or the cost is same. That is an ISO cost line. See, suppose the total amount of money with the producer is Y. Suppose a producer has Y amount of money and price of capital is PK. A producer has Y amount of money and PK is the price of 1 unit of capital. So how many units of capital can be purchased? Y by PK. PK is the price of 1 unit of capital. So total amount of capital that we can purchase, it is Y by PK. Then if you have Y amount of money and PL is the price of labor, then how many units of labor that you can purchase? Y by PL. Y by PL. So Y by PK is the number of units of capital that you can purchase, and Y by PL is the number of units of labor that you can purchase. So in that case, this is the point Y by PK and this is the point Y by PL. So what is the slope of the ISO cost line? Y by PK divided by Y by PL. Y by PK divided by Y by PL. So that is equal to PL by PK. So the slope of an ISO cost line is PL by PK. Price of labor divided by price of capital. So that is the slope of an ISO cost line. Now suppose a producer is getting more money. Then what happens to the ISO cost line? The ISO cost line shifts rightward. There will be a parallel shift because more money is available for both the inputs. So there will be a parallel shift. Now another situation, suppose price of labor increases. Price of labor increases. Then what happens to the ISO cost line? Suppose this AB is the ISO cost line, then this point B will be shifted to the left. A remains the same. There is no change in the price of capital, but there is a change in the price of labor. The price of labor has increased. So this will be the ISO cost line now. On the other hand, if the price of labor decreases, then what happens? The ISO cost line will shift rightwards. Rightwards means only the point B will shift rightwards. Then this will be the new ISO cost line. So in this way we can explain a change in the price of labor. Then what happens to the isoquant? This explanation we can give. The same thing we can explain in the case of capital also. When the price of capital increases, what happens? When the price of capital decreases, what happens? This way we can draw a diagram and explain. Then next topic is least cost combination. Least cost combination. So what is least cost combination? See, or it is also called a producer's equilibrium. So what is producer's equilibrium or least cost combination? A producer will be in equilibrium when he is able to produce a given quantity of output with the least cost. Or when he produces maximum output with a given amount of inputs. So in both ways we can explain the least cost combination or producer equilibrium. Or we can say least cost combination means It is the combination of inputs which cost least to the firm in producing a certain quantity of output. That means a producer is producing a certain quantity of output with the least cost. That particular combination is called, least cost means that will be a particular combination of the two inputs, labor and capital. That combination is the least cost combination. So how we can find that least cost combination? See, least cost combination is attained at that point where the isoquant of a firm is tangent to its iso cost line. We can draw any number of isoquants to a firm and each isoquant represent a particular level of output. But with a given amount of money, there will be only one iso cost line. So when the isoquant is tangent to the iso cost line, at that point we are attaining producer's equilibrium, or that will be the least cost combination. That is the maximum output with the least cost or with the available amount of money. So this is shown in this diagram. We can draw a number of isoquants. These are all isoquants of the producer, but only at one point or with one isoquant the iso cost line will be tangent. When the iso cost line is tangent to the isoquant, that is the least cost combination. See, suppose this is 50 units of output, 100 units of output, 150, 200. See, the isoquants with 150 units, that much the firm cannot produce, that much money is not there. And see, the isoquant with 50 units of output, that is also possible with the given amount of money, but at that cost the firm can produce more output, that is 100. That is the maximum output the firm can produce. So that is the least cost combination. Then what is the condition for least cost combination? At the point of least cost combination, the slope of the isoquant and the slope of the iso cost line both are same or equal. So already we have derived the slope of the isoquant and the slope of the iso cost line. The slope of the isoquant is MPL by MPK. And what is the slope of the iso cost line or the budget line? That is PL by PK. So that is equal to PL by PK. This is the condition, or at this, when this condition is satisfied, the producer will be in equilibrium, or he has attained the least cost combination. See, when you rearrange this equation, you will get MPL by PL is equal to MPK by PK. This is the condition for producer's equilibrium or the least cost combination. When these two ratios are same, that is MBL by PL is equal to MPK by PK. So what is MBL by PL? That is the output that we are getting from the last rupee or last unit of money we spent for labor. and that is equal to the output that we are getting from the last unit of money that we spend for capital. When these two are equal, then the producer is in equilibrium. So that is producer's equilibrium or least cost combination. Just imagine a situation. Suppose MPL by PL is greater than MBK by PK. So that means the producer is not in equilibrium. So how will you bring this producer in the equilibrium position or bring back to equilibrium? What you will do? So now you have spent a certain amount of money for labor and a certain amount for capital also. What kind of changes you will make to come back to the least cost combination? Will you spend more money for labor or more money for capital? So what you will do? See, now MBL by PL is greater than MBK by PK. That means MBK by PK is less and MBL by PL is more. What you will do, or how we can equate these two? You have to withdraw certain amount from capital. How much that is you have to withdraw certain amount that you have spent for capital. When you withdraw certain amount, the number of units of capital decreases. When number of units of capital decreases, the marginal productivity of capital increases. And when you spend that money for buying more labor, or then you can employ more labor, then what happens to the marginal productivity of labor? That decreases. So when you spend more money for the labor, marginal productivity of labor decreases, and when you spend less money for capital, marginal productivity of capital increases. In this way, we can equate these two. So that much only about producer equilibrium. Then next is expansion path. So what is expansion path? See, expansion path is a line connecting the optimal input combinations, that is the least cost combinations. So we are drawing a line connecting the points of least cost combinations. See, one particular least cost combination represents one particular level of output. Another least cost combination represents another particular level of output. So when you are connecting all the least cost combinations for every level of output or each level of output, we are getting the expansion path. Or we can say we can obtain the expansion path by joining the point of tangency between isoquants and isocos lines of a firm. So already we have seen how the least cost combination is attained, that is the tangency between the isoquants and isocos line. So through these tangency points we draw a line, that is the expansion path, and this is a long run concept. This is possible only in the long run. We can increase the quantities of both labor and capital. That is possible only in the long run. So the expansion path is a long run concept. So today we stop here. That much only about isoquants, isocos lines and expansion path.